Hello, my name is Ardi and we are going to solve problem 3.19 from Sadiku book. So the question is use nodal analysis to find V1, V2, and V3 in the circuit of figure 3.68. Okay, so maybe let's assume the direction of the current. I want this to be going down, this going to the right, this going down, this node here, maybe this is going to the right, this node here going down, and then this is going to the right. And for the current source, I just follow the arrow. This is going up and this is going to the right. Okay, this is the ground, so we will have the voltage here as 0. And remember, this node here is 12 volt from the ground. Okay, and we need to do KCL at V1, V2, and V3, right? Let's do one by one. Let's do KCL at node V1. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. What is the current that goes in? That is only from this 5 ampere current source. So we will have 5 on the left hand side. And on the right hand side, what do we got? This current is going out here. So we will have V1 over 4. V1 over 4. And then this current here, that will be V1 minus V2 divided by 8. So we'll have V1 minus V2 divided by 8. And then plus, okay, we will have V1 minus V3 divided by 2. V1 minus V3 divided by 2. And then plus, this current also goes out, so we'll have 3. Let's move 3 to the left hand side. 5 minus 3 is 2. So let's just replace that with 2, right? So we'll have that will equal to 2. Okay, we can multiply this equation by 8 to get rid of all the denominator. So we will have 2V1 plus V1 minus V2, then plus 4V1 minus 4V3. All of that will equal to 16. Okay, and let's simplify this. We will have 7V1. Okay, 7V1. And then minus V2. And then minus 4V3. Will equal to 16. And let's save this as equation number 1. Okay, good. Now let's do another KCL, but this time at node V2. KCL at node V2. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay. And the only current that goes in is this one here. So we will have V1 minus V2 divided by 8 on the left hand side. V1 minus V2 divided by 8. And then this current is goes out. So we will have that will be V2 over 2. And then plus, we'll have this one here, which is V2 minus V3 divided by 4. V2 minus V3 divided by 4. Okay, and I think we can multiply both sides by 8 to get rid of all the denominator. So we will have V1 minus V2. And this one will be 4V2. And then we will have 2V2 minus 2V3. Okay, we will have V1, then minus, that will be 6, minus 1 minus 6, that will be 7V2, and then we will have plus 2V3. All of that will equal to 0, and let's save this equation as equation number 2. Okay, now let's do the last equation, which is KCL at node V3. And the current that goes in will equal to the current that goes out, right? Good. Now the current that goes in is this one here. We will have 3. And then plus this current here, that will be V1 minus V3 divided by 2. V1 minus V3 divided by 2. And then plus this current here also goes in, and that current will be V2 minus V3 divided by 4. And that will equal to this current that goes out here. That will be V3 minus 12. V3 minus 12 divided by 8. Again, we can multiply both sides by 8 from here. And we will have 24. And then plus this one will be 4V1 minus 4V3. And then plus this one will be 2V2 minus 2V3. And this one will be V3 minus 12. V3 minus 12. Okay. Now let's simplify this. We will have 4V1. And then for V2, V2 only came from this one, so we'll have plus 2V2. Okay. And then V3, we will have minus 4 minus 2. So that will be minus 6 minus 1. That will be minus 7. So we'll have minus 7 V3. And that will equal to minus 12 minus 24. That will be minus 36. And let's have this as equation number 3. Okay, so now we have 3 equations and 3 variables. We should be able to solve this. Let's resort to our calculator to solve this equation. Okay, let's set this up. Computation equation solver is number 5. 3 variables is number 2. So we will have 7. And then minus 1. And then minus 4. And we will have 16. Okay, and we will have 1 here. Then minus 7. And then 2. And then 0. And the last one, 4, 2, minus 7, and minus 36. Okay, so we will have V1 is 10 volt. So we will have V1 is equal to 10 volt. And what is V2? Oh, that is not a nice number. 4.933. So V2 is 4.933 volt. Good. And what is V3? V3 is, okay, that's also not a nice number. 12.267. 12.267 volt. And I think this is the final answer for this question. Okay. And I think that's all. See you in the next video. Bye bye.